On today's video, we'll be looking at how to properly diagnose your blower motor. Now, obviously, depending on what type of system you have, the setup is going to vary, but the concept that I'm going to share with you is going to be the same. So right now, on this specific unit, we have a furnace board. And a lot of times when you're new to the industry, you take a look at this board and immediately you're just kind of lost as far as you don't even know where to start. How do I determine if the blower motor is running or not? If you don't have the furnace board, it'll be a more direct approach as far as just testing your wires to make sure you're getting 120 volts. But let's say you run into this system, you see you have your furnace board, you have wires running everywhere. The first thing that I suggest to my technicians is locate the blower motor. So there in the back, we have the blower motor. Now we want to locate the capacitor. So right there, I see the capacitor is on the bottom, and I have my two brown wires connecting to my capacitor. If your blower motor is not working, you may want to start with your capacitor. Replacing your capacitors is as simple as $7, maybe $8. And I would suggest always replacing the capacitor. These are probably the original ones. I do have a video posting on how to replace the capacitor. But once you locate the capacitor, you see your wires are connected. Now you want to find your power and your neutral that's going from your blower to the board. So right now, we're looking for our black and our white wires that are running to this furnace board. So here I have my black, which is going to be my power, and I have my white, which is going to be my neutral. And you want to trace these wires to your furnace board. So here, right in the back, next to this yellow wire, I have my black wire connecting to the terminal on the board. And then I found my neutral. So these are my two wires that at this point I need to diagnose and properly test to make sure that they are getting 120 volts. Right now, the system is off. I unplugged my system that's getting the power from the circuit breaker, as well as disengaged my kill switch. Right now, here I'm at my thermostat. It's in the off auto position. Once I switch it to heat or cool, my blower motor should turn on. It should call for heat if it's on the auto position. If I put it to heat, if I put it to cool, it should call for cool if it's in the auto position. When you put your thermostat to the on position, what you're basically doing is you're just running just a basic fan. What that does is it basically recycles the ambient air inside of your house or your unit. So make sure you're on the auto, and now we're going to call for cool. Right now, nothing is running. The reason is because I unplugged the power source from my breaker to the system, but also here you have your safety switch. And basically, when you put your panels back on the front, once this engages, it'll constantly send power to the system and allow it to respond with your thermostat. When you remove the panel, or if you disengage, even if I plug in my system right now to send the power coming from the circuit breaker, I still won't have power. Once I manually engage this or push it in, that will give power to my system. The reason being is because this is more of a safety switch. In case you're servicing it and you forget to unplug it or remove power from the breaker, you won't, find yourself getting shocked or electrocuted. But you'll see once I push this in, the system's going to turn on. You'll hear my blower motor running. Because I have it on cool, you'll hear the refrigerant running through the pipes. So here my board should light up. So my blower motor is running. I could hear the refrigerant running through the pipes. But right now what we're going to do is we're going to disengage. And the reason we're doing that, as I said, is because we're specifically dealing with properly diagnosing the blower motor. First thing you want to do when you're dealing with your blower motor is obviously checking the capacitor. If you replace the capacitor and you're still having issues as far as the blower motor turning on, you're going to chase those two wires back to your board. We had the black one that was next to the yellow lead, and we had our neutral here in the back. Now what we're going to do is I'm going to tap. I disconnected my wires. You can see right here, I disconnected my power. I disconnected my neutral right here. So they're both disconnected. And now what I want to do is I want to make sure that I'm getting 120 volts from the board to my blower motor. See here, right now I'm tapping both leads. I have my black lead on my power. I have my white lead, and it's barely just tapping the port for my neutral right there. Now that I have my multimeters touching the ports or where the prongs were for my leads that went in, once you pull it, you're just putting the tip of your lead on the prong that's on the board. Once we do that, I'm going to press my safety switch. I'm going to engage it, and my thermostat should get a reading of 120 volts. Here I have my power coming in from my circuit breaker. I have my leads on my board. I'm going to engage the safety switch, and I should get 120 volts once the board picks it up. So here you can see that I am getting 120 volts from my board to my blower motor. Say you had your leads connected to the ports and you're not getting 120 volts. The signal, you don't get the volts going from your board to your blower motor. At that point, what should you do? Most likely the problem is going to be the board itself. So if you put your leads on the board where the wires go in from your blower motor, the hot and the neutral, and you're testing it and you get 120 volts, then you do know the board is working properly. But if you're not getting 120 volts, then you know the board is no longer functioning and you have to replace the entire board. Now the last trick that I would share with you, just to diagnose your blower motor, you replace your capacitor, you connected your blower motor to the board, but you're not getting 120 volts, then you still want to ensure that your blower motor is operating properly. And this is just kind of one more step that you can do while you're up here diagnosing at the furnace. What we're going to do is we're going to make sure we disconnected the two wires. We're going to reconnect our neutral wire back to the board, and then we're going to take this lead and we're going to plug it in here into our kill switch, because we know that right now at this point, once I plug in my system to this outlet is going to send 120 volts here to my panel, and my safety switch is coming from this actual panel where my power is coming in. So what I'm going to do right now is we're going to test with our multimeter so you can see that we do have 120 volts coming in. Right now I disconnected it. Our safety switch is not engaged. My thermostat is on, cool, auto, and right now we're going to go ahead and we're going to open up this panel and we're going to test it for voltage. Here we opened it. We have our power coming in, and we have our neutral and our ground. Here I took my two leads from my multimeter, just inserted it into the wire nuts. They're nice and secure. Here I'm not getting any reading. What I'm going to do is I'm going to plug in. It may not be a plug, you may have a switch on the wall. I'm going to plug it in, and once I do that, I should have a constant reading of 120 volts. So right now I do know that I am getting 120 volts to my system, and what I'm going to do is I'm going to find the live wire that is coming from my electrical circuit or panel right here that's feeding this switch. Unplug our wire that's giving our voltage to our system. Now what we're going to do is we're going to remove our wire nuts to our power supply. We isolated our wires that have the actual voltage that is coming back from our power source, in this case our outlet. When you look at the wires very closely, you can see here on this one just has a bunch of, like, you know, just the surface of it is rough, rugged, and just has those little markers going all the way through. this is going to be your power. The smoother one is going to be your neutral. What you're going to do is you're going to follow your two wires that are coming from your blower motor, your power and your neutral. And what we're going to do is we're going to take the tip of it and we're going to put it on the inside of both of our ports. Be very careful. Right now we do have the power disconnected, but as soon as we power up the system, the 120 volts will go through my prongs, and that should engage the blower motor. Make sure when you're doing this that you don't have your hands anywhere near. Just make sure you're a nice safe distance back. We're going to plug it in right now, and our blower motor should turn on. Unplug your system. These are just a few helpful tips and techniques that you can use when you're diagnosing your blower motor. If you don't have the furnace, you're doing everything but the furnace. You're basically pulling the wires from your blowers and you're trying to get 120 volts to your blower motors. You may have two separate blower motors, so you may have to do each one individually. Again, that's the process you're going to take. You're going to change out the capacitor. Make sure that your fan motor isn't overheated. A lot of times if it's overheated, you'll find that they're thermally protected like your compressors. It'll take some time for it to cool off and then it'll work properly. But if you're in this industry, I mean, you should have capacitors at your disposal regardless. So what I do is when I get a call for a blower motor that's not running, I'll go ahead and I'll replace the capacitor, put my hand on the blower motor, make sure that it's not hot or overheated. If it is, I'll let it cool down a little bit. Then at this point, what I'll do is, if I have a furnace board, I'll test with my leads to check to make sure that I have 120 volts. If I have 120 volts going to the blower motor, then most likely the blower motor is bad. But just as a safety precaution or an extra added step, I like to take the wires and then do this and make sure that I'm actually getting 120 volts directly to the blower motor. And if it turns on, then I know at that point the blower motor's fine, the board needs to be replaced. If for some reason I test my board and I don't have 120 volts, then I know the board is bad because it's not sending the signal to my blower, and that's why it's not turning on. But at that point, even if I see that I don't have 120 volts from my board to my blower motor, what I'll do is I'll still do this process. I'll still get 120 volts feeding directly to the blower motor. If the blower motor turns on, then I know the blower motor's fine, the board needs to be replaced. And if not, at that point, then I know the blower motor is bad itself. If this video was a help, if it was informational, please subscribe.